Hey guys, Dr. Brown here, and tonight we're looking at I think this is the 9th video where we're looking at taking a trig function, raising it to the second power, taking the integral, then we'll take the integral with that trig function raised to the third power. But then we thought, why don't we just raise that trig function to the nth power, and then we can plug in whatever value for n we want. So we've done that for sine and cosine, and now in actually tangent, integral of tangent squared x, integral of tangent cubed x, and tonight we're looking at the integral of tangent x raised to the nth power. So if I were to rewrite this, it's tangent x to the nth power dx. Okay, so you'll know this and that are the same, but I'll write it, most of it like this, so that we can see how the functions work, and it's not so clouded, because if you put all of that above the tangent here, it gets a little messy. So I'll expand it out like this and work through it. Now when you're dealing with tangent and secant are big buddies, just like sine and cosine. So, you know, if you have a sine function, well, its derivative is cosine. And just same with tangent. So if you had derivative of tangent is secant squared. So we can use those functions. There's also another identity. If you have tangent squared, that is secant squared x minus 1. Okay? And we can use that concept. So if we have tangent x to the n, I can subtract 2 from that. Rewrite that as this: tangent x to the n minus 2 times tangent x squared. So it's tangent squared x. I've rewritten that as tangent x all squared. Well, if you multiply these exponents, or these two functions together, and you add the exponents, you have n minus 2 plus 2 is n. So all of this is the same as these above. But the value to doing that is I can now take the identity of that tangent squared x equals secant squared x minus 1, and I can end up distributing that on the tangent x to the n minus 2 and end up with a derivative that has or integral of a function that has its derivative in there, and it just flows really well. So let's go down that path. So let's rewrite this as tangent x to the n minus 2, and we're going to change this tangent squared x to secant squared. I'll go ahead and leave that squared like that. Secant squared x minus 1 dx. Now I'm going to distribute that tangent x to the n minus 2 onto this parentheses here. So I would have tangent x to the n minus 2 times secant squared x dx. I'll change it into two integrals here. Minus, so that's this negative, so I have 1 times tangent, so the integral of tangent x to the n minus 2 dx. Okay, so we've just have this function, and then a negative 1 times tangent x to the n minus 2 dx. All right, so let's let u equal tangent x. Du then is secant squared x dx. So if I isolate the dx, I divide both sides by secant squared x, so I would have du divided by secant squared x, and that equals dx. So if we go back up to our integral here, now we would have the integral of u to the n minus 2, and we're replacing, well, we still have secant squared x, and then we're replacing dx with du over secant squared x. You'll notice the secant squared cancel, and we end up with, I'll pull that back up here because we're going to add this one in the mix in just a minute. The integral now of u to the n minus 2 du minus, so that was this integral here, minus the integral of tangent x to the n minus 2 dx. Alright, so if we integrate this, we're adding 1. That just couldn't be any more sloppy. Sorry. So we add 1, so 2 minus 2 plus 1 equals n minus 1. And when we divide by that n minus 1, so that leaves us down here with 1 over n minus 1 times u to the n minus 1. Well, what was u? U was tangent x. So this tangent x to the raised to the n minus 1 minus the integral of tangent x to the n minus 2 dx. Alright, so that should be the integral of tangent x raised to the n, or tangent n x. So let's challenge ourselves here. And I don't know if you can see very well, but the integral of tangent squared x is tangent x minus x. So if we let n equal 2, let's take this up here. We have 1 over n minus 1 tangent x of n minus 1 minus the integral of tangent x n minus 2 raised to the n minus 2 dx. Okay, so let's let n equal 2. So we would have 1 over 2 minus 1, which is just 1, tangent x of 2 minus 1, which is just 1, minus the integral of tangent x to the 2 minus 2, which is to the 0, dx. Well, anything raised to the 0 just gives me 1, so I have the integral of dx. So I have now tangent x minus integral of dx, which is just x. And that's exactly what we have here. I may need to move the camera just a little bit so you can see those. So you can see the integral of tangent squared x dx equals tangent x minus x plus c. I almost got a minus 1 point there. Okay, so our formulation worked out okay for that one. Let's let n equal 3. We should get 1/2 tangent squared x plus a natural log of the absolute value of cosine x plus c. So n equals 3. Alright, so we have 1 over 3 minus 1 tangent x to the 3 minus 1 minus the integral of tangent x to the 3 minus 2 dx. Alright, so 3 minus 1 is 2, so I have 1/2 tangent x, 3 minus 2, 3 minus 1 is 2. So far 1/2 tangent x squared. But let's not get too crazy. Alright, so now the integral of tangent x to the 3 minus 2, which is just to the first power. And integral of tangent x. Well, I happen to know that is minus natural log cosine x. So minus minus would give me a plus, but just in case, let's keep working here. Alright, so we have minus the integral. Tangent could be listed as sine x over cosine x, since to the first power here, dx. Well, let's let u equal cosine x. Du equals minus sine x dx. If I isolate, divide both sides by minus sine x, I have du over minus sine x equals dx. Okay, so now minus the integral of u, which was cosine x. I still have the sine x up top. And then I have du, I'm replacing dx with du over minus sine x. So that's a negative sine x, and I'm going to move that negative out here before I lose it. Okay, those sine x cancel, so I end up with this 1/2 up here, this tangent x squared plus the integral of du over u. Well, that equals 1/2 tangent x, or tangent squared x, I'll put it back in its normal form here, plus integral of du over u. That's the natural log of u. Well, what is the natural log of u? U was cosine x plus the natural log of the absolute value of cosine x plus c. Alright, so 1/2 tangent squared x plus the natural log cosine x plus c. And that would be, my friend, when n equals 3. Alright, so hopefully you enjoyed these. I think it's kind of cool. Maybe I'm easily impressed, I don't know. Alright, so this was the integral of tangent x to the nth power. So now we can plug in n equals, and it has to be 2 or greater, obviously. So I guess a person could try 4, 5, 6, whatever you want to do there, but obviously with that integral, you get up very high, and it gets a little cumbersome. I'm working on, I guess the next one I'll do is either secant, which we have videos out there on secant x. I don't know if I have secant squared x, but I know I have secant cubed. But I'm also looking at cosecant. I've just finished it actually. So I may do cosecant first. So it'll be cosecant squared, cosecant cubed, cosecant to the n, and then we'll confirm the nth just like we've done here. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying, guys. Work as many problems as you can and keep practicing, practicing, practicing. Okay, good luck with all of this, and we'll talk to you next time. Thanks.